Hi guys, this is Miss Gold. Today's lesson is Module 2, Lesson 8, Develop Rules for Multiplying and Dividing Signed Numbers. Your outcomes for today's lesson are students understand the rules for multiplication and division of integers, and that multiplying or dividing the absolute value of integers results in the absolute value of the product or quotient. The sign or absolute value of the product or quotient is positive if the factors have the same sign and negative if they have opposite signs. Students realize that -1 times -1 equals 1 and see that it can be proven to be true mathematically through the use of the distributive property and the additive inverse. Students recognize that division is the reverse process of multiplication and that integers can be divided provided the divisor is not 0. If p and q are integers, then negative p divided by q is the same as negative p divided by q, or p divided by negative q. Let's start by taking a look at example 1. So they want us to complete the quadrants here, and notice that the different axes represent your integer game. So here we have the number of matching cards that you're going to pick up, and this is the number of matching cards that you're going to discard. These are integers that are positive cards you pick up, and these are negative cards that you pick up. So in this case, notice that if I pick up 3 cards of 2s, so 2 and 2 and 2 would have a value of 6. So this quadrant represents picking up positive cards. In quadrant 2, notice that we are discarding multiples of a card, but we're discarding positives. So in this case, if I discard 2 cards that each have a value of 2, if I discard the first card, then my score would go down 2, and if I discard the second card, my score would go down 4. So this quadrant represents discarding positive cards. In quadrant 3, I am discarding negative cards. So let's say, for instance, I discard 4 cards in which their values are negative. So for instance, let's say I discard 4 negative 2s. In this case, every time I discard a negative 2, my score will actually increase. So if I discard 2 cards, it goes up to 4. If I discard a third card, it goes up 6, and a fourth card, it would actually go up 8 points. So this quadrant is discarding negatives. In quadrant 4, I am going to pick up negative cards. So let's say, for example, I pick up 5 cards where each of the values are -4. So in this case, I am picking up a -4. So what happens is my score goes down 4 points. Then if I pick up another -4, it would go down 8 points. Another -4 would go down 12 points. Another -4 would go down 16 points. And finally, the 5th -4 I pick up, it will have gone down 20 points. So this quadrant represents picking up negative cards. So what I'd like you to do is to go through, I want you to pause the video and fill in each of the quadrants using the integer game. So you need to think about how you are either discarding multiples of a card or picking up multiples of a card and how that would affect the score. When you're done, you can go ahead and continue. So once you're done, check over this solution and make sure that you have all of the numbers correct. So you may need to pause the video again and make sure that all your numbers are correct. When you're done, you can continue. So let's make some observations. What patterns do you see in quadrant 1? Well, what I notice here is every time I pick up a card that is positive, my answer is going to be a positive number. So what I should really see here is a positive times a positive equals a positive. In part B, it says, What relationships or patterns do you notice between the products in quadrant 2 and the products in quadrant 4? So let's look at quadrant 2 and quadrant 4. Now in this case, we have discarding positives or we have picking up negatives. So notice in each of these cases, it involves a positive times a negative, and the result was always a negative. Part C says refer to the completed table to help answer the following questions. What patterns do you see in quadrant 3? So looking back at quadrant 3, we are discarding negatives. And in each case, every time we discard a negative, we know that that's going to increase the score. So all of our answers here were positive. So the final question here is it possible to know the sign of a product of two integers just by knowing which quadrant the integer is located? If we look at our observations, we know that there is a pattern that occurs here. So if we know if it occurs in quadrant 1, we know our product is going to be positive. If it occurs in quadrants 2 or 4, it's going to be negative. And if it occurs in quadrant 3, the answer would be positive. Use the results in the table to work backwards and create quotient equations. So essentially, if we used the table to multiply numbers, we could actually take one of the results and create division problems. For example, I know that 12 was created by multiplying 3 and 4. So what if we said, what is 12 divided by 4? Well, the opposite would be 3. Let's pick out some from other quadrants. Let's say we wanted to know -9. It's divided by a +3. The result would be -3. Let's say from quadrant 3, we were looking at 8. And in this case, let's say we want to divide by a -4. The result would be -2. Okay, let's pick a number from quadrant 4. So let's say, for example, we are looking at -20, and I want to divide it by a -5. My result would therefore be 4. So notice we're seeing the same kind of patterns that we did with multiplication. In this case and this case, our signs were the same. So here they were both positive, here they were both negative, but in both cases, the result was positive. So a product or quotient is positive if the signs are the same. In this case, the signs are different. Here I have a negative divided by a positive, here I have a positive divided by a negative, and in both cases, the result was negative. So a product or quotient is negative if the signs are different. And we have two different ways that we can actually memorize these. One is through the magic triangle. So this is our multiplying and dividing magic triangle. So let's say, for instance, we have -9 divided by -3. I would cover up what I have. So let's say I have a negative, so I'm going to cover this one up. And I have a positive, so I'm going to cover this one up. The one that's left right here is the sign of my result. So my answer is negative. Let's say I was looking at this problem here. I have a negative divided by a negative. So I would cover up my two negatives, and the result would be positive. Another way to memorize this is through a story. So we have good guys, bad guys, coming to town or leaving town. So if we go through this, positive represents a good guy, negative represents a bad guy, coming to town is positive, leaving town is negative. So let's read the story. A good guy coming to town is a good thing. A good guy leaving town is a bad thing. A bad guy coming to town is a bad thing, and a bad guy leaving town is a good thing. So you can see it has the same patterns. So whichever way works best for you to memorize these, go ahead and use it. In this lesson, you have learned to multiply signed numbers, multiply the absolute values to get the absolute value of the product, The sign of the product is positive if the factors have the same sign and negative if they have opposite signs. The rules for dividing integers are similar to the rules for multiplying integers when the divisor is not 0. The quotient is positive if the divisor and dividend have the same sign and negative if they have opposite signs. The quotient of any two integers will be a rational number. If p and q are integers, then if you have negative p divided by q, that's the same thing as negative p divided by q, or positive p divided by negative q. So for example, I can tell you that negative 2/3, there's several different ways we can write this. We can write this as negative 2 over 3, or we can write this as or we can write this as 2 over negative 3. The key here really is that there is a single negative throughout, and that represents that the whole fraction itself is negative.